We're going to do one last example similar to the problem that we just completed. So in this one, we are also given sample data. A hospital researcher is interested in the number of times the average post-op patient will ring the nurse during a 12-hour shift. For a random sample of 50 patients, the following information was obtained. X represents the number of times a patient rings the nurse during a 12-hour shift. And so X, that should be a capital X, is 0 through 5. So we have the fact that 4 patients rang the nurse no times. 8 patients rang the nurse 1 time. 16 patients rang the nurse twice. 14 patients rang the nurse 3 times. And 6 patients rang the nurse 4 times. And one more. 2 patients rang the nurse 5 times. So notice that the value of X is not specified here, but from the context, you can figure out that this first one is for X equals 0, then X equal 1, X equal 2, X equal 3, X equal 4, and X equal 5. So the values of X range from 0 through 5. So our first step is to take those values of X and put them in a probability distribution table in the first column, and then calculate the probabilities for the second column. So if you follow along with the first example, the first probability is going to be for X equals 0. You take the number of patients for that value of X, that's 4, and divide it by the total number of patients in the sample, and that's 50. So 4 divided by 50 is 0.08 or 8%. So if you continue with that idea, you can pause the video and complete this on your own and then check your work. You'll see that we get a probabilities in this column that are going to sum to 100 or 1.0. So pause if you want to work on that, and then come back. Here are the answers for the other values of X. When X equals 1, we take 8 divided by 50, which is 16%. When X equals 2, 16 divided by 50, or 32%. When X equals 3, we take 14 divided by 50, or 28%. When X equals 4, we take 6 divided by 50, or 12%. And then when X equals 5, we take 2 divided by 50, or 4%. So our next step is to take that probability distribution table, add a third column, and multiply the first 2 columns. So here's our third column, X times P of X. We are going to multiply the first 2 columns and put the answer in the third column. So the first answer would be 0, and then we would put 0.16, and then 0.64, and so forth. And these are what you get when you multiply the first 2 columns. You take the sum of this third column, and this is the mean, also known as the expected value or average, symbolized by the letter mu. And so mu is 2.32. And to interpret the meaning of this value, we say that you would expect on average a patient to ring the nurse 2.32 times during a 12-hour shift. And that's what you would expect if you were to conclude or conduct this experiment many times for many patients. So now we want to build our histogram, and this is going to be conducted or done on paper. You make your 2 axes, your horizontal axis that go from 0 to 5, where X represents the number of times a patient rings the nurse during a 12-hour period, and your probabilities on the vertical. I labeled these from 0.05 to 0.45. Now your first probability, let's try to recall these, 0.08, 0.16, 0.32. So you make the height of your bar 0.08, 0.16, 0.32, and then the other heights represent the other probabilities for those values of X. And this is your completed probability histogram. So we are going to answer some probability questions based on this distribution table. What's the probability that a patient doesn't ring the nurse during a 12-hour shift? Well, not ringing the nurse means a value of x of 0. And that probability we said was 0.08. And we could see that here. We could also see it from here. Probability of not ringing the nurse is a value of 0, p of 0, and that would be 0.08, or 8%. The probability that a patient rings the nurse at least 4 times during a 12-hour shift. Well, at least 4 represents 4 and 5, so it's the sum of p of 4 and p of 5. So let's go back and look at what happens when we add p of 4, which is 0.12, and p of 5 is 0.04. Adding these two probabilities, we have 0.16, or 16%. Okay, and the last question, what's the probability that a patient rings the nurse less than 3 times during a 12-hour shift? Less than 3 represents 0, 1, and 2. So adding up the values of x for 0, 1, and 2, less than 3 means 0, 1, and 2. Adding up these 3 probabilities, we have 0.32 and 0.16 is 0.48 and 0.08 is 0.56, 56%. And that is how you do these problems. You have an online homework problem that is very similar to this, and you would do it in a very similar way. So thank you, and I'll see you at the next lecture.